Hi everyone, I'm Chinmay, a graduate student at UCLA, and this is an attempt to distract you from the COVID 19 situation to talk about our work, visual physics, discovering physical laws from videos. I suppose Sir Isaac Newton is the one to blame for this talk. The legend of how he derived the laws of gravitation, seeing an apple fall, is almost like a computer vision problem. Now imagine if a machine could discover the laws of physics by seeing just a bunch of apples fall. So here's what we do. Check out this video of a UCLA student shooting a basketball. I can take a bunch of these videos and then learn the equations of kinematic motion. Or how about this? Here's a motor spinning around. We can discover the sinusoidal motion from videos of this phenomena. So as of today, we are able to take videos of simple physics and rediscover the high school physics textbook equations. Quite cool, isn't it? In the computational imaging community, we are well aware of the hard challenges posed by the physics of light and scattering. Medical imaging and astrophysics are full of scenarios where the exact underlying physics has not been discovered. Discovering the underlying physics for these scenarios hits the bullets of both explainability and interpretability. So, an interesting aspect of discovering physics is that we need to output a symbolic equation from visual inputs, and the machine doesn't know the physics or the corresponding symbols or how to arrange them in an equation. To overcome this problem, we use a multistage approach, where in the first stage, we extract the positions from the input videos. The second stage involves using a time query based VAE or variational autoencoder to process the extracted positions and find the hidden physics in its latent representations. The final equation discovery module takes the processed positions and the discovered physics in the latent embeddings to give the final physics equation as the output. You can refer to our archive paper for further details. Let's have a detailed look at the ball toss result for real data. As you can see, the latent representations of the VAE are highly correlated with initial velocities. The equations are discovered in terms of the latent parameters, and they match the functional form of the textbook equations for projectile motion. Discovering physics is an exciting field, and what's very special about this work is that we don't know the equations or the symbols or the underlying physics. And this is what differentiates us from symbolic regression or other physics from video approaches, which use physics priors like velocity or acceleration for discovery. Right now, we are just scratching the surface of what's possible with physics based AI. The next step is to discover the underlying physics behind scattering, cellular flow in the human body, or discovering the physics of black holes from astrophysical observations. We'll be presenting a more holistic view at the visual physics tutorial at CVPR 2020. You can check out the link for the tutorial on this slide below. Feel free to connect with us in Los Angeles. Social distancing is quite awesome here. You can literally see the sun from the window. Thanks and stay safe, everyone.